Okay, so we've established our baseline in pre-industrial era, and now it's important to learn and understand how we got from there to where we are today. So again, we're going to use the ALCES time machine to take us back and trace the development of various attributes, footprint, or changes in landscapes, natural cover, in the last century or so, in the example that I'm going to show you. So I've expanded the study area here a little bit just to keep things interesting. And you can see here on my time bar, I'm back at 1910. And what we're going to look at is the change in footprint edge associated with minor roads. The majority of these minor roads initially would have been access to farms, ranches, and residential areas, and also some mining operations. But as we moved through the century, the increase in roads is almost entirely associated in this particular watershed with the growth of the forest harvesting industry. So we can see here over on our timeline, again on the right hand side, in 1910, the amount of linear edge density associated with minor roads is quite low and stayed low. There were some increases halfway through the century, but around the latter part of the century in this area, some major agreements were put in place for new forest harvesting tenures, and so we see this rapid expansion in logging roads across this watershed. So let's get the time machine rolling here. I'll just zoom in, pan up a little bit so I can see a little bit better, and I'm gonna click play. So 1910 down here, 1920. You can see the growth coming of those logging roads, but really expanding in a major way in the latter part of the century. So one neat thing too is that I can run this simulation in ALCES, but I can also just grab this slider bar and control it myself, so I can move back and forth. So again, starting off about a century ago, some minor development concentrated primarily around railways and grasslands in this particular watershed, and then just scanning ahead and watching the progressive growth of roads within this watershed. And then in the latter part of the century, a huge increase in linear edge associated with logging roads. Okay, another example, let's look at urban settlements where people live. So this is in the same area. I've zoomed in a little bit. So this is near where I live, and you can see the dark green, there is no urban. And then you see as it gets into yellow, orange, and red is the growth of city areas. So again, you can see the trajectory over time. This is historic data, so I'm just letting this unfold. And you can see the growth of these cities. Actually, I'm just going to move this over so we can zoom in a little bit better and see a little bit more. Let's back it up and start the simulation. So Kamloops is a major city within this area, and you can see that growth occurring with population increase. The other major center is Salmon Arm. So again, one cool thing about ALCES is that what we're doing here is reflecting historic data. This allows us then to understand key attributes like historically what was the relative density of human population in urban areas. So for a given population, how much land did they need? And that then establishes the growth trend that we would expect in the future if we were going to keep doing what we've been doing. So we can examine that and use this information to calculate very important planning attributes. Very neat way of visualizing it as well. One last aspect I wanted to show you then on the backcast. So from pre-industrial time to today, I'm using the black and white color palette here that I talked about, which is useful for screening out for people who may be colorblind, or for just sometimes it makes the attributes that you're interested in easier to see. So what I'm showing here is the Upper Columbia watershed within Canada, which represents about 30% of the entire Columbia River Basin. And we're looking at forest age. So the whiter it is, the younger the forest was in this area. The darker it is, the older the average forest age. You can see down here, black areas are like very close to 200 years on average. So those are getting to be old forests. So the distribution, this is what we had a little over a century ago. More young, as you can see down here, more young than very old. 46% of the landscape at the time was in that second age class, which I believe is like 20 to 40. We got here, yeah, 20 to 4, up to 40 years old. And so actually, with fires and things that were happening in the early part of the century, the age class of the forest was declining. So we can see that as we move through using the time machine, and we see this getting wider and wider, and the forest was getting quite a bit younger. These were a lot of fires that were happening, particularly in the valleys. This is the Rocky Mountain Trench right here, and a number of valleys that you can see where the roads are running up. About the 1940s and 50s in British Columbia, we started to really increase fire suppression efforts in the province, and that actually changed things significantly. Today in British Columbia, we eliminate 92% of all fires within 24 hours. So the effects of that can be seen in forest age class as we move through the second half of the last century. And you see the forest age getting older, significantly older, particularly on the higher elevation areas. So that by the time we get to 2010, the age class distribution is almost even across this landscape, quite a bit different than what it was in 2010. And so we can see that spatial difference very easy and very clearly here. One thing I'll note on this is that we could look at, if we were interested in defining in this graph what was the range of age, say from 1950 through to today, we could actually create a band. So we could put a red band on here, and I could say, well, there's the top end of the range and the bottom range part of the range, about 1950 right there. So that's actually representing the vast majority of variation that we saw over the last century.